Hi everyone and welcome back to PrepFusion. So today we will start with the final lecture of our phasor diagram chapter. So we have totally covered almost every single thing what is required for phasor diagram concept wise. So today we will do more questions on whatever we have learned. Okay, so this is the first question. This came in gate IN. So here we have a time domain expression for v1 of t and v2 of t. Okay, which of the following statements is true? v1 of t leads, v2 of t, v1 of t leads, v1 of t lags, v1 of t leads. So here my v2 of t is the reference. Okay, v2 of t is the reference. With respect to that reference, they are asking where does my v1 of t lies. So let's assume our v2 of t to be the reference. If I assume my v2 of t to be the reference, if I assume my v2 of t to be the reference, that means v2 is vm angle 0. Okay, now what is the angle difference between these two things? Now these are not same, right? This is sine and this is cosine. So let me convert this into cosine as well. Let me convert this into cosine. If I want to convert this into cosine, how can I convert this? So you have to subtract 90 with this, right? If I subtract 90, sine of 90 minus theta is cos theta, correct? So this, right, will be something like this. It will be, okay, something has happened. Okay, my connection got lost. Just hold on a second. Give me 1 second. Think, yeah, now it should be fine. Sorry for the interruption, the connection just got lost somehow. Yeah, now it is fine. So what you do, you know this, right? You remember this thing, that your cos is here, cos of omega t, and your sine is here. Okay, if you are at sine and if you want to represent in terms of cos, so from cos where you need to go, you need to subtract 90, right? From cos, if you subtract 90, you will reach sine omega t. Okay, so what you will do is basically you will write sine of 10t minus 130 is there, so I can write it in terms of minus 130 minus 40, something like this I can write, correct? Minus 90 minus 40, yeah, this is sine. So sine 90 minus theta will be cos theta. Yeah, sine of 90 minus theta. So if I'm here, and no, this will be sine 90 plus theta will be cos theta basically. Okay, so this is wrong actually, so I have to add and subtract 90. Okay, so what we can do, right, this is 130, I can add, subtract 90 and add 90, correct? So like I'm trying to write my sine in terms of cos, so we have to do few modifications. This is the first one. So if I add angle 90 with this sine, then I will get back to cos. So to replicate that, I have to add and subtract 90, because this expression must remain unchanged. So this will be sine of 10t minus 210 degrees, sorry, cos of 10t minus 210 degrees. That is how we can convert this into sine basically, right? So this is vm is here, right? This is my v2 basically, not v2, sorry, this is my v1. So what is the angle of v1? So what is the phase difference between v2 and v1? So phase difference, right, it has angle plus 10, this is minus 210. So overall phase difference is, like, if my v2 is here, okay, v2 is at plus 10, so I have to subtract from v2 how much, 220, to reach to v1, correct? To reach to v1 I have to subtract 220. Okay, so this value, this is correct, right? 90, oh no, sorry, some I messed up. Yeah, this will be 220, right? This will be 220. 130 minus 90, this is 220. So I have to subtract how much? 230. So if I am subtracting 230 to reach to v1, because from v2 how much angle I have to subtract? 230. So if I am subtracting, that means I am moving in the clockwise direction. So I have to move in the clockwise direction 230 degrees. So my v1 will be somewhere around here. Okay, this is my V2, this is my V1. So V2 is at angle 0. I will show you with like another solution as well, different type of solution. This is with angle of minus 230, correct? So this is the difference between V2 and V1. Now there are many ways to see. You can say it like this, that your V1 leads V2 by how much angle? Leads it by, like, if this is overall, if this angle is overall 230 degrees and this is a whole circle, right? So this will be 130 degrees because it is a 360, so this will be 130 degrees. So I can say that V1 leads V2 by 130 degrees. Yeah, sorry for the interruption, my recording got stopped. So I said V1 leads V2 by 130. If this statement is anywhere present, then that will be my correct answer. So V1 leads V2 by 130 degrees, that is present in the first option itself. So of course first option will be correct. Now what can be the other correct? Like this can be MSQ, right? So the other current options can also be that if I flip this, I can say that V2 lags V1 by 130 degrees. From V1, if I move in the clockwise direction to 130 degrees, I will reach V2. So I can say it like this as well, that V2 lags V1 by 130 degrees. Also, we could have said like this as well, right? That V1 lags V2 by 230 degrees. That also can be said because I'm starting from here V2 and I'm reaching V1 in the clockwise direction after 230 degrees. So I can say that V1 lags V2 by 230 degrees. Also it can be said that V2 leads V1 by 230 degrees. That also can be said because if I move from V2 in the anti-clockwise direction, then it will be V2 leads V1 by 230 degrees. Okay, so I hope you understand, right? So there is very high probability that one day a MSQ will be framed. One day a MSQ will be framed from this. Okay. So let me, I will solve it using three methods. This was the first method one. Okay. Second method is that you assume your own reference. So whatever you are comfortable in. So you have assumed sine omega t to be your reference. Vm sine omega t to be your reference, correct? Or simple sine omega t to be your reference. So if you have assumed sine omega to be your reference, you would draw the reference here. Okay, this is my reference basically. Okay, this is my reference, and from with respect to the reference you calculate. So your V1 is Vm 10 sine omega t 10t. So basically omega, right, is 10t basically. So your V1 of t is Vm sine 10t minus 130 degrees. So from the reference I will move in the clockwise direction here. So the V1 waveform will be somewhere around here, correct? Because this is the difference of 130 degrees. Okay, this is my V1. What about V2? So V2 is Vm cos of 10t plus it was 20 or 10 degrees, 10. Okay, so if I want to convert it back into sine again, if you draw the, this is my cos omega t, this is my sine omega t. So if I want to reach from sine to cos, right, like I have an extra lead over the sine. So basically I have extra 90 degrees of angle. So this will be Vm sine 10t, like from sine if I want to reach to cos, right, what I have to do, I have to add extra 90 degrees. So that is exactly what I am doing, plus 90 plus 10. So this ultimately becomes Vm sine 10t plus 100 degree. Okay, So this will be 100, right? 100 will be somewhere around here. Okay, isn't this the same, like similar phasor diagram only? Difference is, like here my reference was V2, so we have shifted whole this thing. If I shift this whole thing on the right hand side, it will be something like this only. Okay, it will be something like this only. So from here as well, you can, of course, you can directly say which one is leading and which one is lagging. So this is 100 degrees. So now if I start from V2 and if I move in the anti-clockwise direction, I am reaching V1 after how much angle? So this is 130, this is 100, so 230 is gone. How much is left? Left 130. So this angle is 130. So from V2, if I move in the anti-clockwise direction, I am reaching V1 after 130 degrees. So V1, because I am moving in the anti-clockwise direction, that means V1 leads V2 by 130 degrees, and with this one relationship you can write all the other three. With this one relationship you can write all the other three which I have described in the previous method. So this was the method 2, but the reference was different. Okay, here this was my reference, this was the method 1 where my reference was V2. Okay, method 3 is there, it is purely a mathematical approach, it is not a visual approach. So it is basically maths. Okay, now what does maths say us? So if I write V2, V2 is Vm sine 10t plus it was plus or minus, I think it was minus 130. Okay, it was minus 130, not V2 is, sorry, in terms of, sorry, I am writing V2, V2 is plus 100 degrees, right? What about V1? V1 is Vm sine 10t minus 130 degrees. Now which one is leading or lagging? Now which one is leading or lagging? Okay, so like what you can do, like from here, right, mathematically saying this is pretty difficult. You can write this V1 like this, Vm, if I add and subtract 360 it does not matter, right? So if I add 360, this will become 10t plus 230 degrees. So of course this has higher angle, so V1 will lead. So previously, right, you might have a cross question, sir, then in this format, when V was in this format, when V1 was in this format, then V1 had a lower value and V2 had a higher value, so that means V2 should have led. Yes, you're correct, but by how much? By how much? In this relationship, if I just take these two waveforms, can you tell me how much V2 leads? V2 leads V1 by how much? What is the angle difference here? What is the angle difference? 230. Okay, isn't that what we proved here? V2 leads V1 by 230. Yes. Hey, mathematically it seems so easy, right? Mathematically it seems so easy, like इतना फर्जी भरा करो, फेजर डायग्राम ड्रॉ करो, कितना कुछ करो, but mathematically कितना आसान लग रहा है, so easy that if I just write these two in terms of like sine only, because you have to write in terms of sine or cos, either you write both in terms of sine or you write both in terms of cos, then you compare the angles. If you compare the angles, you see that yes, in this case V2 has the higher angle, yes, you are correct, but what is the angle difference here? 230. Now if I convert it, but now this option was not present anywhere. If I check here, this option, right, is not present. 120 is present, 130 is present. So what I will do, I will do a bit of smartness, ज़्यादा चालाकी करूँगा. I will add 360 with this V1 because it does not make any difference. If I add subtract 360 with angle, it does not make any difference. So now I will compare the angle. Now who has the highest angle? Now V1 has the highest angle. So now V1, like what is angle difference now? The angle difference now is 130, and now V1 leads V2 by 130. So like it's so easy, right? You don't have to draw any phasor, nothing. Okay, so trust me, this type of methods, and no one will teach you. This is like you are learning something that no one knows, so this is a plus point for you. So if you are enjoying this concept, make sure to like the video and of course comment down below that you have understood this question, like the depth of the concept of this question. So how simply you can solve this question without even drawing any phasor diagram. Okay, so now let's solve this next question where we had to calculate in AC circuit, simple, the voltage VO. Okay, so in this, like, this is just a simple AC circuit you have to solve, and here, right, frequency is given. Frequency is how much? 10. So your omega is 10. You can reduce this circuit, like, even though it is plus minus here, right, it is a sinusoidal signal. Always the sign will not be there. If it is cos, that means you have to understand it is a sinusoidal signal. So in this type of questions, how you solve? First you simplify. So you write this is some Z1 impedance, okay, and this is some Z2 impedance, correct? So what is my Z1 basically? Z1 is parallel combination of the inductive reactance and the resistance. So it is R into J omega L divided by R plus J omega L. Z2 is simply the capacitive reactance. Z2 is 1 by J omega C. That's it. So my circuit will be reduced to this. So my circuit will be something like this. This will be my Z1, this will be my Z2, and of course I have a supply here. Of course, which is sinusoidal. This is uh, 50. Now, right, I can assume few things. Either you can assume like cos omega t to be sinusoidal, or you can assume sin omega t. But here voltage, what is convenient for me, I can assume cos omega t to be the reference, not sinusoidal, sorry. To be the reference, I can assume cos omega t because supply is cos omega t. So I will assume cos 10 t to be the reference. So in phasor, what it will be? It will be 50 angle plus 30. Okay. So what is my Z1 in phasor? So Z1 in phasor, Z1 in phasor will be R. So what is R value? What is R value? R value is 10 J into, now it is 10 T, right? Omega is 10. So 10 into L. L is how much? 0.5, I believe. Yeah, 0.5. 0.5 divided by 10 plus J5. So this is 2 into J into 5 divided by, just I have divided 5 on both sides, 2 plus J. So this will come out to be, now if I just calculate the values, right, so this will be 2 square plus 1 under root into 10. Okay, this does not work. This is 4.47. okay, 4.4721. Anyways, I have to add, like, ultimately, right, my equivalent impedance will be Z1 plus Z2. I have to add. So what I'll do, I will not convert this in polar, I will keep this in rectangular actually. So it will be like I have just cross multiplied, rationalized. So this will be plus 1 square. This will be equals to 2J into 2 minus J. So this comes out to be 2 plus J4. Okay. Now, like, what is my Z2? Z2 is very simple, right? It is minus J by omega. Omega is 10. C is how much? C is 1 by 20. So it will be minus 2J. So ultimately, my Z equivalent or input resistance, right, input impedance is 2 plus J4, Z1 plus Z2, right? It is basically Z1 plus Z2, 2 plus J4 minus J2. So it will be 2 plus J2 basically. Now what will be your, what have they asked actually? They have asked the output voltage. So it will be like a voltage division, right? Ultimately your VO will be a voltage division, because that's why I have written it in terms of Z1 and Z2, because I just simply want to use the voltage division rule. So VO will be input voltage V into Z2 divided by Z1 plus Z2. So Z1 plus Z2 is this 2 plus, and Z2 is basically minus 2j. So VO will be V in. V in is 50 angle of 30 into Z2. Z2 is minus J2 divided by Z1 plus Z2, 2 plus J2. Z1 plus Z2 is this only, Z equivalent, right? So now if I want to write this, so this will be 50, 2 will get cancelled, 30 minus j is there of course, divided by 1 plus j. So this will be somewhat like 1 plus j, right? So under root 2 into angle of 45, this will be 1 angle 90 minus 90, this will be 1 angle 45. So ultimately this side will be very negative number, 50 by root 2 angle minus 60 minus 105. Okay, so like what have they asked? They have directly asked us to calculate the VO value, basically exactly the VO value. So 50 by root 2, what is 50 by root 2? It is 35.535. And what was my reference? My reference was, remember what was my reference? Reference was cos 10t. So it is minus 105 with respect to cos. So cos 10t minus 105 degrees. This will be an answer basically of voltage VO. Okay. So like why am I doing this? Because we are just solving circuits only. Just that the circuits are AC, and don't worry, if you have been given an AC circuit, they will give you a simple AC circuit only. There will be some trick involved, or it will be a simple AC circuit only. It will not be that difficult, because AC circuit involves huge number of calculations, and they don't want you to get stuck in calculations, obviously. Okay, so that is one point. Now let's start with this next question. This is also interesting question. Whenever there is a multi-tone signal, right? So we will learn about AC theorems at the end of this series, AC analysis series. But for now, if there is anywhere multi-tone signals, then what you do? Simply you just use superposition. Superposition I think you have learned. For AC I will discuss the superposition as well specifically, but for now you whatever superposition you apply that. Okay, if you have multi-tone signal, so basically what will happen is that my what do you say? So if I use superposition, right, very interesting thing will happen. If I use superposition, very interesting thing will happen, that what is the impedance of this top one? Generally when these kind of complex circuit will happen, something will simplify. So here if I just calculate this top one impedance, you see that this is omega L and this is minus 1 by omega C, correct? The reactance gets subtracted. So what is omega L? Omega for the first signal, let's consider for omega equals to 200. For omega equals to 200, what happens is this is 200 into 2.5 minus 1 by 200 into C. What is C? C is 100 micro. So it is 10 raised to power minus 4. Okay. So this becomes what? This becomes how much? This is basically 25 into 50. This is 50 minus this is how much? 10 square by 2, that is 100 divided by 2, that is also 50. So ultimately, right, the top one becomes 0. And whenever a resistor or a finite resistance is connected with parallel a short circuit, basically the short circuit dominates. This you have been taught in networks. I know you have been taught in networks. Short circuit would dominate for the first signal. For omega 1, omega equals to 200, this will be short circuit. So basically this resistor has no use. Basically it is totally short circuit. If it is totally short circuit, then what happens? Then how does the circuit behave? So for omega 1 equals to 200, this component is basically totally short circuit. If it is short circuit, what happens? How can I replace the circuit? Circuit will be something like this. It is short circuit, and this is my some impedance here. I'm not concerned about that impedance. That this is my input Vi and this is my output, correct? So basically my VO is equals to Vi when omega equals to 200 radian per second. So this thing is sorted, right? This thing is sorted. For omega equals to 200 radian per second, VO equals to VI. That's it. There is no problem with that. Now let's go into the next one. Let's go into the next one. Okay, if my for 500 radian per second, for 500 radian per second, what will happen? Of course, this one cannot contain, again resonance cannot happen. You can check, you can verify, you will see that no, your omega L and they are not simplifying. But let's check this one. No, let's check this one, what is happening. So if I check this one, what is happening is that if I check the secondary circuit, omega 2 equals to 500 radian per second. So if I check this circuit, this is what, like, how is the parallel calculated? Parallel is calculated like this. It is like this, let's say, is giving XL and this is giving XC, correct? So it will be J into XL into minus J into XC divided by JXL minus JXC. It is basically that formula, right? Z1 Z2 divided by Z1 plus Z2. That is the parallel formula. So let's check if this denominator is going to 0 or not. Like, it will go to 0, and this, you will say, sir, how do I like do all these things? I don't know whether to check the denominator or not. You will learn this in resonance, because there is some resonance condition. So resonance, automatically it will be in your mind and you will check that. Okay, don't worry, in resonance this will be cleared. So what is the XL in this case? Again, it is omega L. Omega is 500, L this time is 0.4. So it is 4 into 50, that is 200 ohms. What about XC? XC is 1 by omega C. So 1 by omega C is 1 by 500 into, again, 10 microfarad. So it is 10 raised to power minus 5. So this will be 10 square, will go 10 cube by 5. 10 cube by 5 is 200 only. So of course, again, this denominator goes to 0. If this denominator goes to 0, my equivalent impedance seen of this circuit, right, is infinity. Infinity. If it is infinity, that means what? That means it behaves as an open circuit. If this behaves as an open circuit, that means no current will flow through here. If no current flows through here, whatever the current here, the same current here, right? And of course, this is the point from which I am taking the output. It is not like a current will flow, just I am measuring the voltage. So if I measure the voltage, it is open circuit. So here also there is zero current. So of course, again, my Vi is simply equals to V only. Again, my Vi is simply equals to V only. So for omega equals to 500 radian per second as well, my VO is equals to Vi only. So basically my VO equals to Vi for these two signals. So it will be 2 cos 200t. 2 cos 200t is here, and it will be 4 sin 500t. 4 sin 500t is in the option B. So option B will be the correct answer for this question. Like, trust me, if for electrical guys this is a cakewalk, but if some question, something like this comes in EC, right, maximum chances are there something like this will happen. Either it will become short circuit, that is resonance, or it will become open circuit. It will be simple. Trust me, it will be something simple. For EC guys, I'm telling, they will not give you something very, very difficult. Trust me this. Okay. So what is happening here? Okay. Something is wrong. Yeah. So this is also a very, very good question. So here we have to find out the voltage V in if the current through AB branch is given as 1 ampere. Current through the AB branch is given as 1 amperes. Okay. So first thing is this that they have not told you anything about phase. They have not told you anything about phase. So what phase you will assume? You will assume this to be in the zero phase only, because they have not told you, right? They have not told you anything about phase, so you will assume it to be in the zero phase. So how do you calculate the current through this impedance? So current through AB should be equals to voltage across AB divided by the impedance ZAB. Do I know the voltage across AB? No, but I can calculate the voltage across AB, right? Because I know what is the impedance, I know what is the current. Current is simply 1 amperes. What is the voltage? Voltage is, sorry, what is the impedance? Impedance is 30 minus J40. Okay, so this is the voltage across AB. Now can I find out this current? Yes, Ix. I can find out this current Ix. Ix will be what? VAB divided by, this is a different impedance, right? This is ZX. So VAB is 30 minus J40. As they have not provided any reference, I have assumed this to be 0 degrees. Okay, so this will be Zx is how much? 30 plus J40. So now I can rationalize this one. So this will be 30 minus J40 whole square. Okay, and this will be 30 square plus 40 square. That's it. Or like simpler approach will be, simpler approach I will tell you, this is 50, like if you remember the formula, this is what lying in the fourth quadrant, so minus tan inverse 4 upon 3. 4 upon 3 I have told you to remember, it is 53.13. so this will be 53.13 degrees. Like you can put in calculator, you can use that, and this will be 50 only, this will be plus 53.13. so overall this will be one angle minus 106.26 degree. This will be the current Ix. So like ultimately they have asked me to find the voltage. To find the voltage, right? I already know VAB, just I need to find out the drop across this. So what will the drop across this will be the current into the resistance. So current will be what? Addition of Ix and I. So current I will be Ix plus 1 ampere, the current that is already given. So Ix is 1 angle minus 106.26 degrees plus I is 1 angle 0 degrees. Okay, so now like you can do the simple computation. So again I have to convert this into rectangular because I have to do the what do you say, I have to basically add the two quantities. So 106.26 minus cos, this will be minus of 0.28 plus 1 is there already, minus j 106.26 minus sine, so this is 0.96. so this will be 1 minus 0.28 0 point minus 0.96. So like you can write this in terms of angle or you can keep it as it is, it's totally up to you because we have to ultimately add. So let's keep it as it is, right? So my VR, voltage across the resistor, will be R into I. So very simple, right? R is 5, so I have to multiply 5 with it. So 5 into I, so this will be 5 times this is 0.36. If I multiply, not 3, sorry, 3.6 minus, if I multiply 5, this will be 4.8. okay, this will be 3.6, this will be 4.8. now what is the voltage V in voltage will be the addition, KVL, right? Simple KVL you apply, V in will be addition of this drop plus with this VAB. So VAB I already know and VR I have just found out. So VR plus VAB, so VR is how much? VR is 3.6. it is not much actually, it will not change the answer much, plus VAB. VAB is 30 minus J40, so it is 30 minus J40. So ultimately it comes out to be 33.6 minus J44.8. so your answer will be 33.6 whole square plus 44.8 whole square under root, it is coming out to be 56 an angle. Okay, 56 an angle. How much is the angle? Angle is basically, this is in the fourth quadrant, right? Because the y is negative. So 44.8, 33.6 tan inverse minus 53.13. Now is there any other method to solve this question? Yes, there is. Method 2, this was the method 1. What is the method 2? Method 2 is without calculating this Ix. I don't want to calculate this Ix, directly I want to find I. So what you can do, you can use the current division method. Current division method. if I use the current division method. So basically, if I use the current division method, I know that this current, right, let me name this current as Iy will be, let me name this impedance as Zx, this is Zab, correct? And I hope you remember the current division rule. It was I, the input current, into the opposite impedance Zx divided by the summation of both the impedance Zx plus Zab. Directly, without even calculating the value of Ix, I am directly calculating the value of I from here. So what will be I, because Iy I already know. This is method 2, current division. So Iy I already know, it is 1. Zx is 30 plus J40 plus Z AB is 30 minus J40. So things are simplifying. Divide by 30 plus J40. Okay. So my I comes out to be, if I just divide, this will be 2 into 3 basically, divided by 3 plus J4, because I am dividing by 10 on both sides. This will be 2 into 3. Yeah. So now what else you can do is, what is your R is 05, right? So you can write this in, actually you can write this in 6 into, if I cross multiply 3 minus J4 on both sides, 3 minus J4, this will be 5. Yeah, this will be 5 only, not 5, sorry, this will be 25. Okay. So now what is the voltage across the resistor? It will be 5 times I. So this will come out to be 6 by 5 into 3 minus J4. Now my V in will be VAB plus VR, same formula, just I have used the current division rule, that's it. That is the only difference that I have done, except that everything is same only. What have they asked? They have asked the find the voltage they have asked. So yeah, so you can easily calculate now. So this will be VAB is what VAB is 3. If you remember, VAB we just calculated, we didn't not calculate, but we did it previously, calculate VAB, right? It was 30 minus J4. This was the first thing that we did. So 30 minus J40 plus 18 by 5. 18 by 5 is 3.6 minus J 24 24 by 5. 24 by 5 is 4.8. So it comes out 33.6 minus 44.8, almost approximately it is the same only, that it is coming out, the magnitude is coming out to be 56 volts and angle is minus 53.13, just like the previous one. Okay. So yeah, the answer of this question is 56 angle minus 53.13. So let's move on to the last question of this whole chapter. So we have to find the phase angle of current I with respect to the voltage V1. Okay. So V1 voltage is there. With respect to voltage V1, what will be the phase angle of I? With respect to the voltage V1, what will be the phase angle of I? So again, right, what you can do, either you can find out the equivalent, you can replace this whole thing with the equivalent impedance. You can replace this whole thing with the equivalent impedance and you can add these two voltages. Okay. To solve, find the value of I. To find the value of I, you can add, because phasors can be added, right? Phasors can be added. So what I will do is I will convert this into a equivalent circuit. So in the equivalent circuit, what is happening? I am converting this into a impedance. Z, and what will be this Z equivalent? I will tell you Z equivalent, and the source also I am adding. These two sources I can add, right? Because they have not told me anything about frequencies, I will assume they are both same frequency. I can simply add. If I add these two, ultimately if I add these two, what is coming? If I add these two, basically this will be V1 plus V2 equals to 100 volts. V1 plus V2 not 100, sorry, this plus j and minus j cancels out, so this will be 200 volts. Okay, I will not change, right? Just I have changed the circuit, like this I have made it together and this I have made it together, that's it. I will not change, correct? So what is Z then? Z will be the parallel combination, Z will be the parallel combination of the resistor and the inductive reactance divided by 10 plus J10. Okay, so from here can I have easily find out I? Yes, I can. So your I will be V upon Z, so it will be simply equals to V is how much? 200 angle 0, okay, and by Z, so it is 100 J into 10 plus 10 J, so it comes out to be 100 cancels out, this is minus 90, minus j goes there, this will be minus 10j and this will be plus 10, so ultimately it will be 20 minus j20, okay, 20 minus j20. So this is my current. In phasor can I write this current? Yes. In phasor what will be the angle? Angle will be minus 45 and magnitude will be 20 root 2. Okay, what about the voltage V1 source? Because they have asked me with respect to V1 what is the phase angle. So with respect to V1, what is the phase angle of V1? The phase angle of V1 is basically 100 root 2 angle plus 45, tan inverse y by x, and this is in the first quadrant. So the phase difference, so I can comment that I, because here, right, it is negative, it is positive, so the phase difference is 90 degree. Phase angle between V1 and I1 is 90. So I will write phase angle between V1 and I1 is 90 degrees. This will be an answer. Okay. One more thing, I can also write that V1 leads I1 by 90 degrees. This also I can write, V1 leads I1 by 90 degrees. Okay, or you can write that I1 lags V1 by 90 degrees. Both works. Not I1, sorry, this is I, right? They have asked for I. This is not I1, I. So with this we have end our phasor diagram. If you did enjoy this whole chapter, if you learned, like if you are a dropper students, I know you must have learned many new things, I know this for a fact. Okay, so yeah, if you did enjoyed this whole chapter, please do comment down below, please like the video, that helps us, like it if you do the appreciation, right, it helps us like be motivated to post more videos. So yeah, from the next lecture onwards we will start with a new chapter, that is locus diagram. That will be a very short chapter, and after that we will start with the most important topic, that is resonance. So thank you for watching, and I will see you in the next lecture. Until then, happy learning.